In this video, we will try to understand Pitter NPL gauge interferometer. So in the last video, we have understood NPL interferometer. It is the working principle will be almost similar to NPL interferometer. Slight deviations will be there with respect to the parts present and the arrangements of the parts, but the basic principle will be same as that of the NPL interferometer. Interaction between the light waves will help us to get the fringe pattern. From the fringe pattern, we will try to understand the height of the slip gauge here. Okay, so this is the major difference. In an NPL interferometer, we have used to check the flatness error, whereas this Pitter NPL gauge interferometer is used to check the height of the slip gauge. That is the purpose. Okay, another important thing you should know is that here we'll be using cadmium light source, whereas in the NPL interferometer we have used mercury vapor lamp. Here we are using cadmium light source. Okay, and we have to make sure that highly controlled physical conditions are maintained for the proper functioning of this Pitter NPL interferometer. Like it should be kept at 20 degrees Celsius at a pressure of 760 mm mercury. Okay, water pressure of 7 mm. Okay, and it should contain 0.33% of carbon dioxide by volume. Okay, so these are all the conditions under which this Pitter NPL gauge interferometer should be operated. Okay, so you can see it from the figure. It has a monochromatic light source which is usually cadmium. Okay, it is condensed with the help of a condensed lenser. Then it is passed through this illuminating aperture. From illuminating aperture, it falls on this collimating lens, which transmits parallel light waves. From the collimating lens, it falls on this constant deviating prism. Okay, which has the capability to split the incident light into light rays of different wavelengths, and hence we get the different colors. Okay, the person who is operating the Pitter gauge interferometer can select a desired color by varying the angle of this constant deviating prism. Okay, relative to the plane of base plate. So if you vary this angle of this constant deviating prism with respect to this base plate, we can get different colors. Okay, from the constant deviating pressure, the light waves falls on the optical flat and slip gauge and base plate. Okay, so the light reflected from the optical flat, slip gauge and base plate will travel back and fall on the viewing aperture, and depending upon the fringe pattern, we can easily calculate the length of the given slip gauge. Okay, so how this fringe pattern get formed was already explained in the NPL interferometer. You can check that also in the previous video. Okay, so the fringe pattern that we got from this Pitter gauge is shown in the figure, and the height of the slip gauge can be calculated using this relation. H is equal to n lambda by 2 plus a by b into lambda by 2. Okay, so n is nothing but the number of fringes that we are observing. Fringes observed. Lambda is the wavelength of the light source, and a bar b is the observed fraction. Okay, you can see here in the picture, this fringe pattern was formed because of the interaction between the light source from the optical flat and base plate, whereas this fringe pattern was formed because of the interaction of the light source from optical flat and slip gauge. Okay, so you can see what is A and B from the figure itself, and you substitute this, we can easily calculate the height of the given slip gauge. Okay, to summarize, we have seen what is the purpose of pitter in-peel gauge interferometer. It is used for directly checking the height, and we have seen that we are using cadmium light source in this pitter gauge in-peel interferometer, and we have seen the working conditions that has to be maintained to operate this interferometer. And based on the formula given here, we can easily calculate the height of the given slip gauge. Okay, thank you.